Okay, class. Grade 7. We're on lesson 5 now. Fundamental counting principle. Like I told you, every lesson is connected to the first lesson. So it is important for you to understand lesson 1, lesson 2, lesson 3, lesson 4, and now lesson 5. You need lesson 1, 2, 3, and 4, and 5 to do this. Okay? Now, in this lesson, you will need this table. This table that we saw in lesson, I think it was in lesson 1. Let me show you the table, because you will keep on referring to it to make decisions, okay? So, I'm finding the lesson 1. That's lesson 4. Quickly. Come on. Wait. Yes. You see this table? You will need this table to make that decision. Okay? This table, you need it. Alright. So make sure you have drawn that table in your notes. Draw it again. Draw it again in lesson 5. Because you need to refer to it while making decisions, okay? Alright. Wait. What lesson is this? Almost there. This is what? Simulation. And then lesson 5. Okay. There. The fundamental counting principle. Very easy. Okay? Now, don't confuse this principle and the principle the way we write Modira. Those are two different things. One is a person, the other one is a statement. So principle with the A is Modira. Okay? And principle with an E is a statement or a theorem, okay? Like that. Don't confuse those two words, two different words. All right, now, what does the fundamental counting principle say? This is in your book. If event M, so if one event has M possible outcomes, you may have one outcome, might have 3 outcomes, might have 2 outcomes, yes? And you have another event, you have a second event, and you're calling that second event N, okay? It will have N possible outcomes. You may have 3 outcomes, 2 outcomes. It depends on the tool that you're using, whether it's a spinner, a coin, or a number cube, okay? It depends with the tool you're using. The event M followed by the event N means you multiply the outcomes that are in M and the outcomes that are in N, and this will give you all the possible outcomes in that probability. We will do an example, okay? So instead of you, remember I said when you wanted to find the sample, the outcomes, you needed to know the sample space. After you know the sample space, then you arrange your sample space in a table or a list or a tree diagram. So here we are saying you don't have that time to do a table, you don't have time to do a tree, you don't have time to do a list. You don't have that time. So instead of doing all that, table, list, and tree diagrams to find how many outcomes you have all together, we are saying just multiply. If you multiply the number of outcomes in all your events, it will give you the total number of outcomes in that experiment or in that probability, okay? So that's what I wrote here. Do not draw a table or write a list, or draw a tree diagram. All you have to do is use multiplication. That's all I wrote over here to get. So to get the samples, to get the outcomes in the sample space, to get the outcomes, to get the total outcomes, to get the total outcomes in the sample space, okay? You use multiplication. Now, let us look at this question here. Find the total number of outcomes. That's what the question wants. The total number of outcomes. When you see this question, you will use the fundamental counting principle. So find the total number of outcomes when a coin means one coin. It didn't say coins with an S, it said a coin. A coin means one, is tossed, and a number cube, one number cube. Okay, it didn't say cubes, it said cube, is rolled. So I wrote what they want. They want one coin and they want one number cube. And we say to find our answer, we shall multiply. Then I wrote my sample space. I wrote my sample space for the coin. I know there are two of them. I wrote my sample space for the number cube. I know there are 6 of them. I multiplied my two outcomes and I got 12. So my total number is 12. And this 12 is what I did. I used the fundamental counting principle. So this probability has 12 outcomes. So that's what I wrote. There are 12 different outcomes. I wrote my answer in numbers and I wrote my answer in words. Okay. Now, I did example A. Find the total, the keyword there, the total number of outcomes. That's what the question said it wants. They're telling you when choosing from bike helmets that come in 3 colors. There, that number is what I was looking for. And 2 styles. You should know how to read numbers in words. You should know how to read numbers in number form. So, 3 colors, 2 styles. So I wrote there, 3 color sample. You choose any 3 colors. I chose pink, purple, red. You can choose red, black, yellow. You can choose blue, green, white. It doesn't matter. Whatever 3 color, but you only need 3 colors. And you need 2 styles. 2 styles. So I said my styles will be glitter and rainbow. Somebody can say the helmet can have a visor, like a mask in front, like that, okay? Or can have a strap on the chin, like that. So the design really doesn't matter, whatever you want to make the design to be. So I said my helmets will one can have glitters and another can have ribbons, okay? So there's 3 outcomes for the color and 2 outcomes for the styles. How many outcomes altogether? I have 6 total outcomes, and I wrote there the total number of outcomes is 6, and this is my answer in a sentence. Now, you make sure you remember this. You can use the fundamental counting principle to help you find the probability of events. So that means the last you find the probability of this. So let's look at an example. Here is the question. Find the total number of outcomes. So you have to answer this question. And what did they say they gave you? From unrolling a cube, a number cube, with 1 to 6. The cube has 6 outcomes. 6 values in the sample space. Or 6 outcomes, I agree. And then you are choosing a letter from the word numbers. Keyword there. You're choosing a letter. Then they said, find the probability of rolling a 6 and choosing an M. Okay? So, here. Sample space for number cube, I wrote them out, 1 to 6. 1, 2, 3, 4, 5, 6. Sample space for numbers is all the letters in numbers. Numbers. How many outcomes? 6. How many outcomes? 7. 6 times 7, 42 outcomes. I have answered the first question. The question asked me find the total number of outcomes. That I have answered. Then the question is asking me find the probability of rolling a 6. Find the probability of rolling a 6 and choosing an M. And I wrote that. So I said probability of getting a 6 and a probability of getting M. How many 6s are here? 1. 1 out of how many? 1 out of 6 outcomes. 1 out of 6. How many outcomes are here? 7. How many are M? Only 1. So 1 out of 7. I multiplied. 1 times 1 is 1. 6 times 7 is 42. I changed my answer to decimal and percent. And there, I have answered the 2 parts of this question. Now let us continue. Here is a question. Find the number of different ice cream flavors option available at Baskin-Robbins. Then find the probability of randomly selecting a strawberry scoop, a vanilla wafer cone, and sprinkles. Is it likely or unlikely that the ice cream strawberry will be chosen? You need to answer that question also. Justify your answer. So you have question 1, question 2, question 3. You need to do 1 to be able to answer 2. You need to do 1 and 2 to be able to answer 3. Now let us see how to answer that. So the question gave you a table. You have flavors, cones, and toppings. How many flavors does Baskin-Robbins give us? They give us vanilla, strawberry, rainbow, chocolate, and mint. They have 5 flavors. Then how many different cones do they have? They have vanilla cone, a vanilla wafer, a chocolate wafer, and a plain wafer. So they have 3 different cones. How many toppings do they have? They have 3 different toppings. They have sprinkles, they have nuts, and they have M&Ms. So those are 3 different toppings. Now we want to find the number of ice cream flavors total. That's what the question says, yes? The total number of options. You take the number for flavors, the number for cones, and the number for toppings, and you multiply all of them. 5 times 3 times 3 gives us 45 total outcomes. Okay? Then, what do we want? Strawberry. According to the question, you want strawberry, vanilla wafer, and sprinkles. How many strawberries do you have here? 1 out of 5. How many vanilla wafers? You have 1. Vanilla out of 3. How many sprinkles? You have 1 out of 3. Then you multiply. I got 1 out of 45. I change it to decimal, and then I change it to percent. Then I need to answer this. Is it likely or unlikely? Now, since my number is 2%, I wrote, it is unlikely. Well, I should write very unlikely. It's very unlikely for a customer to choose this option because 2% is less than 50% and it is closer to 0. That is why I said very unlikely, because it's way closer to 0. Okay? Now, let us do example B. Okay. Right, let us do example B. So, they told you 2 number cubes. How many? 2. You see, I read over here. Are rolled. What is the probability that the sum of the numbers, sum means you need to add. Sum means you need to add 2 numbers, one from the 1 cube, the other one from the 2nd cube. Alright, so what is the probability that the sum of the two numbers on the cube will be 12? Now, I wrote my sample space for cube 1, 1 to 6. Sample space for cube 2, 1 to 6. I multiplied them. I got 36 outcomes. They want a sum of 12. How do I get 12? Because all my numbers are positive, I'm going to use positive numbers. To get 12, I add 1 to 11. There is no 11 here. I cross it out. I don't need it. To get 12, I add 2 to 10. There is no 10. I get it out. To get 12 is 3 plus 9. There is no 9 in my number cubes. There is a 3, but there is no 9. So I don't need that. To get 12 with 4, I need 8. There is no 8 in my sample space. I erase it. To get 12 with 5, I need 7. I don't have 7 in my sample space. So I have 6 and 6, which I have here and here. So how many do I need? One of them. I only can get one if I use my number cube. So that's what I wrote. So the probability of getting the sum of 12 is 1 out of 36. I change 1 out of 36 to a decimal and then a percent. Then I answer the question, how likely is it that the sum would be 12? It is very unlikely. I think the keyword there should be very. Very unlikely. It is very unlikely to get a sum of 12 when you roll two number cubes because 3% is less than 50 and closer to 0%. That's the reason why. Or you can write because it is less than 25%. Because it is less than 25%. Use your table. Okay? Use that table that we saw in lesson 1 to make your decisions. Now, this is example 4. Here, a box of toy cars contains blue, orange, yellow, red, and black cars. A separate box contains a male and a figure and a female action figure. That means it has a doll, two dolls. One is a male and the other one is a female. Okay? So you have two boxes. Here you have cars. Here you have dolls. So you have a female doll, like a girl, and a boy doll. So those are called figures. See, female action figures, another name for dolls. So you have there. And here you have black, blue, what else you have? Orange, yellow, black, blue, orange, yellow, and red. There you go. So your cars come in this color, your dolls come in these options, okay? We continue reading. What is the probability of randomly choosing an orange car and a female action figure? You only have one orange out of 5, and you only have one female out of 2. There's 2 of them, female is 1. There is 5 cars, orange is 1. Okay? So now let's see how I did it over here. I wrote my sample space here. Blue, orange, yellow, like that. Male and figure. Then this is 5, this is 2. I have 10 outcomes. After I found my outcomes, I knew my denominator has to be 10. So this helps me check here. Then, probability of orange car is 1 out of 5. Probability of female is 1 out of 2. If I multiply, I get 1 out of 10. Then I change it to decimal and percent. And then I said it is very unlikely. It is very unlikely because 10% is less than 50 and closer to 0. Or it is less than 25%. You can write that. Okay, so do Aleph, and then I see you on Sunday, inshallah. Bye.